Welcome to the Tech Study channel. In the previous class, I have explained ER diagram for banking schema. Now, in this class, I will explain ER diagram for university schema. So, first we will see what is relational entity relational data model, and then we will see ER diagram, entities, attributes, relationship types, means mapping cardinalities. Each mapping cardinalities in relational database. So first, what is entity relationship model? So it is based on notion of real world entities and how they interact and the relationship between them. While formulating the real world scenarios, the ER model creates entity set, relationship set, general attributes, constraints to mapping out system data. So it uses relationship set entities and attributes to construct a diagram, means to construct a design of the database, and it is based to use for conceptual design of database. It is based on entities and their attributes and relationship among them, among attributes and entities. We already know, I think, in real world that we want to give information about. And then attribute is the entity's property, the entity having a property called attribute. Domain, every attribute is defined its own value called domain, like integer, varchar, like that. Integer is for numbers and varchar is for text. So this is used associated with domain is associated with the attributes in the table, so that we can insert in a particular value a set of values. Okay, other than that it will not accept. And then relationship, the logical association among entities are called relationships. The mapping coordinates defines the number of associations between two entities. There are one to one, one to many, many to one, many to many. We have discussed this already, so I am not explaining that. And then naming and conventions, though these are important for um, um, creating a diagram for ER model. Okay, so these are ensures essential rules that clarify and consistency when designing the database or data model, by which the technical team and business stakeholders can be read. And then entity rules are using singular nouns like a student, not a students. Okay, starting with capital letters or entirely uppercase, and every entity must be unique name. And avoiding technical jargons, like instead of using utilize, we have to use word. Okay, and instead of terminate word, we have to use stop word. Like that, many will be there. Okay, and for attributes, using singular nouns and using camel case or starting with capital letters. Means camel case means except first word, remaining all other words are starts with capital letter. Okay, using entity name as a prefix to clarify attributes, like customer address, employee address. Primary key must be underlined. And for relationship, using present tenses verbs, like works for or enrolls. It should not be used like worked or enrolled, like that. Okay, the names can be readable from top to bottom and left to right. Okay, top to bottom and left to right. Okay, and symbols, entities except weak entity, all entities are represented by rectangle, weak entity double rectangle, relationship rhombus, identifying relationship double rhombus, attribute oval, key attribute underline plus oval, a multi-valued attribute double oval, derived attribute dotted oval, total participation in of E2 in R is indicated by double line, and cardinality ratio 1:n of E1:E2 in R. Okay, and 1 to many relationship. Okay, from E1 to E2. And structural constraints, minimum comma maximum on participation of E in R. Means if we consider a student entity, then the minimum number of students which are participating in this relation, means relation can be enrolled in a course, participated in a sport, like that. Okay, So if minimum number of students are participated in the relationship, then that value is considered as minimum. And if the maximum number of students participated in the relationship are called maximum. Okay, yeah. And then we will come to ER diagram. ER diagram of university schema. Here is the it is the ER diagram. So entities are student, course, subject, lecturer, department, and dependent. Okay. These are represented by rectangle, and attributes represented by ovals like relation, department, dependent name, lecturer ID, lecturer name, like all these ovals. Okay. And then relationships represented by rhombus or diamond, like belongs to, manages, enrollment, teaches, enrolled in, like that. And then has also. And types of entities: strong entity, an entity that exists independently of other entities. Example: student, lecturer, course, subject, and department, because it has its own primary keys, which are indicated by oval and underline. Student ID, customer ID, lecturer ID, and subject ID, and department ID. These are the strong entities because it has its own identifier, means primary key, which uniquely identifies each rows in the table. And then weak entity, an entity we can't be uniquely identified by its own attributes alone and depends on a strong entity. So here represented by double rectangle, department means family member entity is depends on lecturer entity. Here is this dependent is depends on lecturer entity. Okay, because weak entity contains partial key. So partial key means which combines with primary key of strong entity and uniquely identifies all rows in the weak entity table. So that's why this department dependent name combines with lecturer ID and uniquely identifies each row in this dependent table. So dependent can be a family member, or relation is a son, example, and dependent name is full name. Okay. Dependent means it is an attribute whose values are depends on other attributes. Okay. So dependent in DBMS refers to an attribute whose values relies on another attribute values, known as the dependent. Okay. So here partial key column values are depending on lecturer ID column values. So it is according to the definition of a dependent. And then tangible entity, a physical object, student, lecturer, and family member. So here why it is means a physical person employed to teach, it's a lecturer. And student, if a physical person enrolled in the university. Family member, a physical person related to an employee. And it's a physical person, means tangible and intangible, means physical and imaginary, means real and imaginary. Okay, we can consider it as a real and imaginary. So course, a program of study, it's a logical thing. And subject, a specific unit of learning, it is also logical thing. And department, administrative unit, while it may have an office, the department itself is a legal and structural concept. So that's why we are considering it as an intangible entity. And then associative entity, a relationship that is treated as an entity to link multiple entities together. Means what's the difference between relationship and associative entity? Means relationship is the association between entities is called relationship, and associative entity means it holds the relationship, means association between two entities, and it holds its own attributes. Okay. Example is enrollment connects a student to a course. So here this enrollment is an associative entity which has its own grade column, means grade attribute. Okay. And then types of attributes. Partial key is here full name or dependent name, we can say. Okay. Key attribute, a unique identifier, an entity of an entity. Okay. Of an entity. So examples are student ID, department ID, and course ID, lecturer ID, and subject ID. So which are underlined in the diagram, those are the key attributes, means also called as primary keys. So which are used to uniquely identify each row in the table. And simple attribute, an atomic value that can't be subdivided. Department name, lecturer name, student name, course name, subject name. So these subject name we can't divide further. And department name, lecturer name, department name, and lecturer name, where it is, and student name. Okay, which can't be subdivided. Okay. And then composite attribute, an attribute that can be divided into smaller subparts. Example, address composed of a pin, state, and house number. Here we have this address attribute, which is a composite attribute which is divided into subparts. So that is pin, state, and house number attributes. But these attributes can't be divided further. Okay, because they are simple attributes. These composite attributes are divided into simple attributes. Okay. And then single valued attributes holds only one value for a specific entity. Example, date of birth, student ID, customer ID, subject ID, lecturer ID, and department ID. So each student has only a single value. Okay, that is student ID, and each course has a single number, that is customer ID, and subject ID, and lecturer ID, and department ID. Those are also unique and single only for each subject, each lecturer, and each department. And date of birth of a student is also a single value. Okay, like a student can't hold two date of births. Okay, that's why it is called single valued attribute. Similarly, in the student ID, customer ID, and subject ID, and lecturer ID, department ID, the particular persons can't hold two values of it. Okay, multi-valued attribute then can hold multiple values for single entity. A student having multiple hobbies. So here we have a hobby attribute is there, which is indicated by double oval. So multiple hobbies are there, like reading, writing, walking, like that. Okay. And then derived attribute whose value is calculated from other attributes, like age derived from date of birth. Here is the age and date of birth, which is represented by dotted oval. Okay. And then we have mapping cardinalities in the university schema, ER diagram of university schema. So mapping cardinalities means number of associations between two entities. And so the tables are department tables, are lecturer tables are is there, and subject table, student table, course table, and dependent table. These are the actual tables. Okay, so through this we will establish a relationship between two entities. Okay, so one-to-one relationship between lecturer and department. One lecturer manages one department. So what is the definition of one-to-one relationship in relational database? Means each row of first table relates to exactly one row in the second table, and each row of second table exactly relates to exactly one row in the first table. This is the definition of the one-to-one relationship. So in case of lecturer and department, so here we have lecturer and department. One-to-one, lecturer manages department. This is the one-to-one relationship. Here is the explanation is, we already know we are making statements from left to right and then right to left. So those are like this: one lecturer manages one department. Okay, example 101 and 1005 manages department 101 and department 102 respectively. Here in the table we can observe this is the output table, which is department table. We are updated department table, so we got the output table. Okay, this is called output table. Okay, here 101 1 L, this is L. Okay, L01 L001 L002 L001 and L002, these each lecturer ID is related to exactly one department, that is L001 related to D101 and L2002 is related to D102, means linked to D102. Okay, and then one department is managed by exactly one lecturer. Opposite statement from right to left, that is one department is managed by exactly one lecturer. Example is D101 and D102. Each department is managed by L001 and L002 lecturers, means exactly unique lecturers. The both department IDs have unique lecturers. Then primary key of one entity is usually placed as origin key to the other. Means this is the rule for creating a output table for one-to-one relationship. Okay, so we can put here we have department table and lecturer table. So we can put the primary key of this table in the lecturer table as a origin key, and we can achieve the output table. And we can also put primary key of lecturer table in the department table as a origin key. Okay, to get the output table. So here we have applied the second method. So we can apply any one method. Okay, because the rule is saying like that only. Okay, and then we have one-to-many relationship between course and subject. So here one course can have multiple subjects. Example, we are stating a statement from left to right. Okay, one course can have multiple subjects, like C01 have S501 and S502 subjects, means one course has multiple subjects, and each subject belongs to exactly one course. From means stating a statement from right to left. Each subject means in a set of subjects, each subject belongs to exactly one course. Example is S101 and S102 belongs to one course, that is C01. And here the origin key goes on many side. We already know the rule for one to many, as I have said in the previous class, that is the primary key of one side table is placed in the many side table, in the one to many relationship and in the many to one relationship also, to get a output table. Okay, so how to decide one side table and many side table means by generating a statement according to uh, cardinality. If it is one to many, then this statement is satisfied for this mapping cardinality, means one is in the order it is first, and here also in the order it is first, and many is in the order second, and here also multiple is in the order second, means it is placed first and it is placed second, it is placed first and it is placed second. So this statement and mapping is matching. So that's why we consider course table as one side and subject table as multiple side or many side. So according to that, we place the primary key. So here many type is subject table, many side table is subject table. So we are placing course table's primary key in the, so we are placing course table primary key in the subject table as a origin key. Okay, that is here. Okay, then we got the output table by updating subject table. Okay, means we are inserting the course ID. Okay, and then we have a many to one relationship between student and department. Student and department, many to one relationship. Student enrolls in department. So here many students belongs to one department. Okay, example is 101 and 102 belongs to one department, that is D101. Okay, these two students are belonging to only one department. So many students are belonging to one department. So we got a statement from left to right, that is many to one, and then for right to left, each department can have many multiple students. Like example, department D101 have multiple students, that is 101 and 102. Means we have stated the statement for one to many relationship. And then origin key is placed in the many side, many to many. Okay, origin key is placed in the many side. So we have generated a statement using according to mapping cardinality, that is many to one, that is many students belongs to one department, means student table is many side and department table is one side. So we are placing department tables primary key in the student tables. So by updating student table means inserting department id as a origin key, we got the output table and we have established a many to one relationship. Okay, and then many to many relationship between student and course. A student can take many courses. From left to right, we are making one statement. Okay, that is a student can make can take many courses. That is student 101 is appeared twice in this table and took two courses, C01 and C02. Means we have made a statement from left to right, means many to many. A student take many courses. Okay, and a course has many students. Reverse, many to many. Okay, we can say each student also. So here example is C01 has two students, 101 and 102. Okay, so that's why each course has many students. So that's why we have generated a statement from right to left. Okay, this requires a separate table, junction table, associative table. Means associative table means which has their own grades. Okay, so here we have in the diagram student to course relationship is there, many to many. So here in relationship is what? Enrollment, which has a attribute grade. So in the enrollment table we are inserting a grade attribute along with relationship. So these are origin keys. These are also origin key. Okay, which are taken from student table and course table. Student key and course, student ID and course ID. So origin key can have repeated values. So that's why we have repeated courses and student IDs. Okay, so we have established an output table by bringing primary keys from actual tables, student table and course table, primary keys, student ID and course ID, using as a origin key in the enrollment table, and a new attribute which is held by associative entity. Okay, and then many to many relationship is established here, and then relationship between the lecturer and dependent. Here is there lecturer and dependent. There is no mapping cardinality between them. Okay, only I'm explaining the how to develop a relationship, how to establish a relationship between a lecturer and a dependent. So since dependent is a weak entity, its table must include primary key of the strong entity. So it is a weak entity. As we all know, it has only partial key which can't alone uniquely identifies each row in the table. It requires primary key from the strong entity, and it combines with that primary key, and both will together uniquely identifies the dependent entity, means dependent table. So its table must include primary key of the strong entity. Here strong entity table is lecturer table. Okay, lecturer as a part of its own primary key. Okay, so here we are in the department table, we are placing lecturer ID, that is L001 and L001 as a 4 region key. Okay, so this is a partial key and all, as well as 4 region key, and this department name is a partial key. These both together uniquely identifies these rows. Okay, so we already know the property of partial key, that is each value of primary if each value of partial key should own its should be uniquely related to primary key value. Okay, means if we consider lecturer ID as a partial key, then for that the department name will become primary key, and if department dependent name, okay, dependent name, if we consider it as a partial key, then lecturer ID becomes its primary key. So if we consider lecturer ID as a primary key and dependent name as a partial key, then each value in the partial key must be uniquely related to lecturer ID value. So here Sarah is related to L001 and Mark is related to L001. These are two different entities which are related to L001 lecturer ID. These are two different values of the partial key, means each partial key is related to unique value of the primary key, that is lecturer ID. Okay, means we can't write Sarah L001 and Sarah L001, that becomes data redundancy. Okay, to avoid that we are the partial key property is useful. Okay, so that's it for today's class. If you have any doubts, ask me in the comment section. If you feel this video is helpful, then subscribe, like, share and comment it, and hope this video is helpful and understandable. I will see you in the next class. Thank you. Bye.